I'm Derick Winkworth, otherwise known as Cloud Toad on Twitter. And I've done several of these NFTs before. I actually know some of you maybe had a few drinks too many with one or two of you, which is maybe will happen again this week. And I'm going to show you some integration work we've been doing with OpenDaylight and with our data services engine. Yeah, so actually, right before I got on the plane to come here this time, we got hit by a blizzard in Wisconsin, and that was unfun. Had to get up a couple hours early and remove a whole lot of snow, even with the snowblower, because of the depth of the snow. And that has been me. Just finished shoveling the driveway. Now I got to go back out again. So, well, in addition to the work I've been doing, obviously for Plexxi. Yes. So Niels mentioned, Niels had a slide up here that was sort of to the left where it doesn't matter. Anyway, we talked about doing integration with group policy, this group policy proposal with that's in OpenDaylight.
I mean this slide?
That would be the magic slide. Where we had these sort of policy frameworks off to the left. And what's happening is, in this diagram, is we're pulling those policies in. Like, for instance, we've been working with Cisco and Semi. They have that group policy, the Semi contract policy is the group policy that was proposed for OpenDaylight. We're pulling those policy constructs in, or that sort of policy database in, and we're analyzing it, and we're deconstructing it into a set of basic relationships, which are affinities. From those affinities, because what they really represent, it's really kind of hard to talk about it because it's so simple. And I've said this before, as I said at the last one, it's really just a very basic relationship. You have a container and another container and a relationship between that container, and you populate in those containers network identifying criteria. Things like IP addresses, MAC addresses, et cetera. And what you're saying is there's a relationship there. So what do you do with that relationship once it's specified? Well, that depends on the metadata that's attached to the constructs. You can attach metadata to that relationship when you build it, right? You build a group, then you specify the relationship, then you attach metadata to that relationship that describes what you want to happen between those containers. So our CEO, Dave Husak, and I were having a conversation, probably this is a while back, and he said something that was really awesome. He said he was using his hands to talk, right? And he was very vigorous and very enthused, like he usually is. And he said, just like networking, it's better to disaggregate things at higher software levels. And he used this motion, two hands together and like this. And that really struck a chord with me because when we're talking about having a Plexxi infrastructure surrounded by other infrastructure, which, to be honest, happens in almost every case. There is no such thing as a pure Plexxi environment. It's usually surrounded by something else because we don't make routers and firewalls and things like that. So, what the question that kind of popped in my head was, if we have a relationship, an affinity that we're defining, how come other things can't consume that relationship in a useful way? Or, why can't we leverage those other things to help us make that affinity real? And in this demo, which Niels is pulling up, that's exactly what we do. We specify some affinities into OpenDaylight with metadata attached, and some of that metadata is consumed by OpenDaylight, but some of the data is consumed by Plexxi. So, you want to pull that up?
You mean this one? Or do you want?
Sure. Well, this is just
what screen do you want to have?
Actually, pull up OpenDaylight.
Okay.
So what we have displayed here is a Plexxi ring flanked. It's one of my favorite words, flanked. I don't know why. Flanked by OpenFlow switches, right? We have an OpenFlow switch over here, and we have an OpenFlow switch over here. We have host 1, host 2, and host 3. And right now we actually have a ping running between host 1 and host 3. So why don't we look at the flows, Niels, under the troubleshooting tab. Click on yes. And we see some flow entries that were learned and programmed into the OpenFlow, in this case, ODL VS3, that facilitates traffic between host 1 and host 3. So what we'll do here is actually create a tap. We're going to say that we want traffic from going from 1 to 3 to be copied out to host 2.
To give you the...
Actually, I'm going to do that on this one over here.
This is the TCP dump.
And this is actually a TCP dump on host 2, and now we can see that the ICMP echo is being copied. So why don't we go back to OpenDaylight and refresh the flow list. And the tap created this entry, which basically you can have multiple output actions in an OpenFlow entry, and in this case we're outputting, we're still, actually why don't you go to ODL, the flows on ODL VS1. Nope, yes. There we go. It's still output, ODL VS1 OpenFlow switch is still outputting towards the Plexxi ring. It's also outputting towards host 2. And then you can have multiple outputs, just means copy. What did not happen in this case, Plexxi does not actually support natively a tap affinity. So when we applied that tap affinity, nothing actually happened inside of the Plexxi ring. But through the northbound API of OpenDaylight, we can actually add another piece of metadata to the same relationship. So we're going to add an isolate attribute. What's interesting about this, conversely to the tap one, is OpenDaylight has no concept of isolate, but Plexxi does. So OpenDaylight will ignore the attribute, but Plexxi will pick it up and do something with that.
Do you want to show the Plexxi GUI on the screen?
Yes.
It's the IP on that, right?
This is a well-rehearsed demo, but it's working. The demo's working.
10.1?
No, 10.10. Or no, 10.20. Slash.
Yep, getting there.
Oh, there we are. Right, and go to affinity groups. Select all. So actually, one thing that we did do was we automatically created the groups that were inside of OpenDaylight and just have them sitting there because there's no cost to doing that. If you don't apply any policy to them, they just hang out like an access list that isn't used, let's say. So when we added the tap affinity, those groups were created. So now we're going to actually add a relationship, an isolate attribute to the relationship. And within so many seconds, as you can see on the bottom, it picked up that relationship, and it's rerunning a fit of the network. But because of the size, I don't know where it is on the screen. I'm sorry. It's there, but because of the resolution, it's not showing up inside the pane.
I'm sure.
No, it's true. It's true. You have to believe me.
see it perfectly, right?
Yeah.
I can see it.
Maybe it's the
Yeah,
font color.
it's
Maybe
awesome.
the font or what?
Oh, there we go. There it is.
Look at that.
Hey, there it is.
True, you have to believe me.
Yeah. See?
Now we believe you.
Well rehearsed demo. So it actually, so when we added the isolate attribute, it actually created how we visually depict the affinity in our inside the controllers with this arrow saying traffic going from group A to group B. We want to isolate that traffic within our fabric. That appeared when I added the isolate attribute. It would have been way more impressive if it actually visually had the impact I hoped it had, but that's what happened. If you think about this though, you know that there's lots of discontiguous systems that you need to configure to support flows in your network. So what if host 2 had a firewall sitting in front of it and you wanted to add a firewall rule for each thing that you tap? You could actually apply metadata to the relationship that isn't consumed by OpenDaylight or by Plexxi, but by a third thing. Let's say something that's represented on the DSC by a module that goes out and programs, reads that affinity, sees a piece of metadata that says firewall X, and then makes a call to the relevant firewall and adds the rule. The point is that we can deconstruct, or we can apply this metadata to the affinities and have them consumed by the surrounding systems to automate things. And we can actually have those affinities consumed by multiple disparate systems to take independent actions on that relationship.
Hyperglance?
Yeah, show them hyperglance.
All right, so we'll after all the screen swapping, we'll see what Hyperglance has for us. Funny thing is, the thing let me just quickly go through a screen where you can see. That's impossible here. So the thing Hyperglance does is that, as said, it takes all the information topology, in other words, the hosts, nodes that are there, the links that exist between those nodes or between those hosts. It takes the flow information from OpenDaylight and basically projects that in sort of a 3D model. So if you
and as you can see, host 1 and host 3, if we zoom in, they're actually throbbing.
Yes.
Yeah.
Gonna talk about flank again?
Maybe they're breathing. Maybe that's more appropriate. They're breathing, not throbbing.
Oh my God.
Now the thing is, we've got. Let's see if I can move here to the side. So the intent is that you have a very large screen that has these tabs here on the side, and what I've done here, or the visualization on the on Hyperglance side, it allows you to select either a node, it allows you to select a path, allows you to select a link, which you see at the right-hand corner some information, or an endpoint, a sort of directional one side of that link. Now what we do is we're zooming in on one individual link here, and specifically through Hyperglance, we're pulling out all the information, including the flow that is representative of particular traffic that was sent through, and the packet count that came with it. In other words, from a single host, single pane of glass, we can go in and basically figure out sort of how is this stuff connected. I can go in and hide individual hosts, or select hosts based on a filter that I can specify here. For instance, I can specify a filter that says every host of vendor X, which is a piece of metadata that might be available to Hyperglance. So I'd say, long story short, from a Hyperglance perspective, what these guys are trying to solve for is, if you have an entire end-to-end infrastructure, you need to troubleshoot it, then you've got 40 different systems to do that in. Why not start with one that has a consolidated view of most of these individual network pieces, and then through individual actions kind of drill down to next layers down. in a couple of weeks, we'll have a demo together with the guys from Real Status, and they'll go through some stuff, including sort of network actions that can be taken from this particular network view, as well as individual sort of go-to actions that can be taken from an individual node that you're seeing here. Now, if you don't like a 3D view like this one is, there's also a way to basically select give me the 2D version, which would kind of mimic your traditional Visio files that are printed locally. Off to you.
Yeah. This is one of the great benefits of OpenDaylight. By exporting our information into that tools that are built to extract information out of OpenDaylight can certainly be used to obviously visualize and manage a heterogeneous infrastructure, right? In this case, we have OpenFlow and Plexxi. And those OpenFlow switches are actually OBS instances. So we can actually layer stuff in, like I was kind of hinting at earlier, maybe, is things like chef, et cetera. So you could make these sort of policies, layer in data services on top of them, and then be able to dynamically enforce based on indirect references to nodes such as chef roles and other things.
So I have a question here, and part of this is just my lack of knowledge around all of this. Like, I get bits and pieces of it. So we keep talking about all this orchestration, pulling data from one segment to the other. You guys are referencing Chef a lot. Is Chef kind of what you guys see binding a lot of this together, or is it all the orchestration engines, or is it what you choose to be the orchestration engine? Because the network stuff I get, the ODL stuff to you guys, just passing variables and stuff around, but then you've got how you interact with OpenStack, or how you interact with vSphere, how you interact with whatever your data center management platform might be.
Sure. So there's lots of tools like Chef that have information about what nodes are, right? When we reason about what we want to do with the network, it usually starts way before we talk about IP addresses. We say things like these web servers should XYZ, right? And the thing is, we can actually use tools. If someone's using a tool like Chef or Puppet or CF Engine or Ansible or OpenStack, there's actually metadata inside those tools that tell you what your web servers are. So you can, any of those tools would be useful to actually reference. So when you make your policy, instead of putting IPs in, you actually put in references to classes of things in these tools. And we think that's incredibly powerful, right? If you're using Chef to deploy web servers, that's a great way to know exactly what your web servers are. You can get all your IPs and all your MACs for all your web servers from that tool.